Today's video, we're going to find the formula for the time period of a physical pendulum. So let's say there's a body that is rotating around a pivot point P, and it has its center of mass at the point Cm. So we can make a free body diagram here, and weight is the only force that's acting on it. And because of this weight, there's going to be a restoring torque. So torque equals, the restoring torque is going to be D cross W. And D cross W, we can find it because we know this angle theta can also be put here. This one's also going to be theta. So the restoring torque is going to be negative dmg sine theta. And the reason it's going to be negative is because it's a restoring torque. Torque can also be expressed as the moment of inertia times the angular acceleration I alpha. So we can solve for alpha by putting these two together, by setting these to equal to each other. So we get negative dmg sine theta over I alpha. Or sorry, not I alpha, just I. So we know that the formula for theta at any given time t is theta m, which is the maximum theta, times cosine omega t plus phi. And if we differentiate this twice, we can get alpha, which is negative theta m omega squared cosine omega t plus phi. And now we can substitute theta into the alpha equation. So alpha, which is angular acceleration, is equal to negative omega squared times theta. So we can set this equation and this equation equal to each other to get a relation. So negative omega squared theta equals negative dmg sine theta all over I. And the reason I said small oscillations at the start is because theta is approximately equal to sine theta when theta is less than 15 degrees. So we can, and also here theta is in radians. So we can cancel out theta and sine theta because I specified that it's small oscillations, and also the negatives cancel out. So we're left with omega squared equals dmg over I. Now, omega can be expressed as 2 pi over time period because 2 pi is 1 full revolution, so 1 full revolution over time period is the angular velocity or angular frequency. So now we substitute that in, so we get 2 pi over t squared equals dmg over I. And now we just have to solve for t. So we can bring the square root to the other side, so we get 2 pi over t equals square root of dmg over I. And the reason we're not doing plus minus is because the negative case, we can get rid of the negative case because its time period is a scalar quantity. So t equals 2 pi times the square root of I over dmg. So, if you like this video, please like and subscribe. Thank you.